Let's talk the real number system. After today's lesson, you should be able to determine, analyze, and compare rational and irrational numbers. Why are we talking about rational and irrational numbers? Because those are two of the major categories within the real number system. Now, the real number system is composed of a lot of different types of numbers, but the two major categories that they all fall within are rational and irrational numbers. Let's look at a few of these categories and try to build some understanding for what makes the difference, what makes a number rational, what makes it irrational. The main thing that I want you guys to understand is that anything that falls on this side as a rational number can be written as a fraction where b does not equal 0. Because obviously we know we can't divide by 0, and when we do, it is undefined. So let's talk about some examples of rational numbers. You see here that we have integers, we have terminating decimals, we have fractions, and we have repeating decimals underneath that first layer of rational numbers. So what are integers? Let's start there. One, integers are whole numbers. That includes 0 as well as natural numbers. Natural numbers are the numbers that we use to count. And usually we start with 1 and we continue on into infinity. Those whole numbers make up integers. Integers also consist of the opposites of those numbers. So that would be the negative 1s, the negative 2s, the negative 3s, okay? So if we wanted to come up with a definition for what integers were, it would be whole numbers and their opposites. Now let's talk about terminating decimals. Terminating decimals are those that end, I mean, it's right there in the name. So what would a terminating decimal look like? It could look like 1.35. That is a terminating decimal. Now remember that all of the numbers that fall within the rational category can be written as fractions. So how could this number be written as fractions? Well, we would read it as 1 and 35 hundredths. So that would be 1 and 35 hundredths, okay? Obviously, fractions would be a rational number, right? So any number that can be expressed as a fraction is a rational number. And we also have repeating decimals. That would be a number like, with this bar notation. Whenever you see this bar notation, that means the pattern continues on into infinity. And as I stated earlier, all of the numbers that fall within the rational number category can be written as fractions. And I'm just going to show you really quickly how this can be written as a fraction. So I'm going to let x equal my repeating decimal. Okay. Now what I want to do is I want to create a whole number. So I'm going to multiply my repeating decimal times 10. And when I do that, if I multiply my repeating decimal times 10, I'll get 3.33. And then remember, we're still working with my repeating decimal. And the whole object of this exercise is to get rid of everything that's to the right of the decimal. So this part represents what I had to do to my repeating decimal in order to create a whole number, which is this. And this part represents the repeating decimal. So all I'm going to do now is solve for x. So 10x minus x gives me 9x. And 3.33 minus 0.33 gives me 3. Once I solve for x, I'm going to divide both sides by 9. And I will end up with x is equal to 1/3. And if you guys do the math on it, 1/3 is repeated 3. Okay? So I just wanted to show you guys really quickly of how repeating decimals can be written as fractions. So I was not lying. All right, so we talked about all of the numbers that fall within the rational category. We got integers, which are the whole numbers and their opposites. We have terminating decimals, which are obviously decimals that can end, right? We have our fractions and we have our repeating decimals. So those decimals that you see with the bar notation. Now let's talk about the irrational numbers. The irrational numbers are those decimals that do not terminate and they do not have a pattern. So an example of that would be, let's say 1.35678 on into infinity. This decimal does not terminate because it continues on into infinity, and there is no repeated pattern, okay? Another number that is irrational that we all know so well is pi. Oftentimes, we look at pi as this rounded number that represents 3.14, but that's actually just the rounded number. Pi actually continues on into infinity, so it is also an irrational number. All right, so let's do some fill in the blank, and we're going to move kind of quickly through these, but feel free to pause the video whenever you need to get down your notes. The natural numbers, okay, the numbers that we are that we naturally start counting by, like 1, 2, 3, are counting numbers without 0. Okay, so counting numbers include 0, natural numbers do not. Whole numbers include the natural numbers and 0. So a 0 is also a whole number. Integers include all whole numbers and their opposites, okay? Rational numbers are real numbers that can be written as fractions, where a and b are integers and b does not equal 0. Remember I told you you can't divide by 0, it will give you an undefined. Any rational number can be expressed as a terminating or repeating decimal, okay? So not only can rational numbers be represented as fractions, we can also represent them as either terminating or repeating decimals. Irrational numbers are any real numbers that are not rational, okay? Again, feel free to pause this video to jot down any notes that you need. All right, so now let's look at a number line. We're going to label our number line from -7 to +7. One thing that I want you guys to remember is that our negative values are always to our left, and our positive values are to our right, okay? And right in the middle is 0. Right in the middle is 0. All right, so now that we have our number line created, we're just going to plot some of these numbers that they've given us. So right here, we're going to plot these numbers. So we have -3/2. Some people will look at this number and think that it is -3 1/2, but it's not. It's -3/2, which is when you do the division, it's -1 1/2. So it would fall right here, okay? Let's look at 2.7. 2.7 falls in between 2 and 3, okay? 5.9 falls in between 5 and 6. And pi, which we know is an irrational number, falls between 3 and 4, okay? So the main thing that I want you to get from this demonstration is that fractions, decimals, rational, irrational, all those numbers exist on the real number line. All right, so let's answer some of these questions and just really work on just really solidifying our knowledge about rational and irrational numbers. Which direction do the negative real numbers go on the number line? The negative numbers go to the left, okay? Which direction do positive real numbers go on the number line? They go to the right. Where does the real number 0 go on the number line? It goes right in the middle, okay? True or false, and explain your reasoning. Is -3 less than 5? True. The reason why -3 is less than 5 is because it is to the left of 5, okay? It is to the left. If you look at a number line, you will see that -3 is to the left of 5. -7 is less than -3. This is also true, because I want you guys to remember that the more left you go, the smaller the value, okay? The more right you go, the bigger the value. So -7 is to the left of -3, so it is also less. What do positive and negative numbers mean? So all of these numbers on the page kind of give us an idea of whether or not it's a positive or whether or not it is a negative, okay? So we're going to go through these these words, and I'm going to draw either a plus sign or a minus sign to indicate whether or not they're positive or negative. So if we're talking about decrease, that is negative. A surplus means extra, so that is positive. Loss, negative. Deficit, meaning shortage, is negative. Credit, positive. Debit, they're also used at the same time, is negative. Increase, positive. Gain, below sea level, above sea level. Add, and subtract. Okay? Feel free again to pause the video to take down any notes that you need. All right, so let's read each statement and determine whether or not it is positive or negative. Kalamazoo is 780 feet above sea level. I lost $5 betting at the track. The temperature decreased by 7 degrees. I dove 7 feet below sea level. I made $143 on stock. The temperature warmed up by 3 degrees. 10-yard penalty. Okay. How do you find the opposite of a non-zero real number? We're going to flip the sign. And the sign refers to positive or negative. So let's look at an example. If it is a positive 679, the opposite would be negative 679. If we're talking about a negative 34, the opposite would be positive 34. If we're talking about a positive 13, the opposite would be negative 13. If we're talking about a positive pi, the opposite would be negative pi. We have reached the end of our presentation. I hope that you guys by now feel a lot more comfortable about what the real number system is and what categories fall within it. The main thing that I want you guys to remember is the two major categories are rational and irrational numbers. Always remember that the big difference, rational numbers can be expressed as fractions and irrational numbers cannot. Until next time, bye guys.